Hello, and welcome to the third day of the Advent of Code 2022. Let's get started first reading the statement. Okay, and one elf has an important job of loading all of the rack stacks with supplies. Each rack stack has two large compartments. All items of a given type are meant to go into exactly one of the two compartments. Okay, so there are two compartments. The elf that did the packing failed to follow the rule for exactly one item per rack stack. The elves have made a list of all the items currently in its rack stack, the puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, an A referred to different, that is, okay, A and A, upper or lowercase, are different items. The list of items for each rack stack is given as a character of all on a single line. Okay. A given rack stack always has the same number of items in each of its two compartments. So the first half of the characters represent items in the first compartment, okay, while the second half of the characters represent the items in the second compartment, okay. For example, the first rack stack contains the items V, J, W, G, W, R, which means its first compartment contains, okay, the first half are the first compartment and the second. While the second compartment contains the items, the only item type that appears in both compartments is lowercase p. The second rack stack compartment contains this. The only item that appears in both compartments is L. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase items have priorities 1 to 26, and uppercase item types 27 to 52. In the above example, the priority of the item type that appears in both compartments of its rack stack is 16, blah, blah, blah. The sum is this. Find the item type that appears in both compartments of its rack stack. What is the sum of the priorities of these items? Okay. Let's start by copying the example and working through the example. So 3.py, what we can do, we're going to sum the number of each element that appears twice, right? So how do we find, for a given string, how do we find the elements that appear twice? So we can do, we could say solution of the first part equals 0. So for line in open 3.x, we're going to read the line, and we need to see the element that appears in both places, right? So this character that appears in both, in the first, here we do this, we don't need to do the strip of the line. So what we can do is we can take the lines until the length of line divided by 2. So this is the first half of the line, and we can do a set of this line. And if we intersect with a set of line from len line divided by 2 till the end, we can see what is the character that appears in both places. Okay, this is wrong. Must be integers. I think we need to do an integer division. Let's see. Okay, PL. Exactly. There's one single character that appears twice. So if we get the first element, I think we could also do this next. It would get the first element. Let's see if that's right. No. We need to convert to a list. Maybe there's a better way. Later we will refactor the code and think if there's a better way. Okay. Oh, sorry. List is not an iterator. We just need to take the first element. Okay, so this, and now what we need to do is get the number of this character. So I think we need to. There is a method which is ORD. I think if you get this, okay, it gets the ASCII code of this character. So what we can do is we can sum the ORD of C minus. So if this is A to Z, so I think there is also A dot is lower. Is that correct? Yeah, is lower. So we could do if C dot is lower, what we can do is sol1 plus equal ORD of C minus ORD of A plus 1, right? Else, we need to sum minus A plus 27. Print so on. Let's see if this works for the example. 774. So this is wrong. Oh, here we are summing this, which we don't need to do. Yeah, it's 157. So it seems we have a solution. Let's try to run this through the input. Okay. So if we edit 3.in, we paste this. I don't know what's wrong. I think I'm going to edit. I'm going to save this file. And then I'm going to run this with the input. So 7,7831. Submit. We got the gold star. Okay, that was quick. Let's see this. Let's find about the second part, and then we will refactor this code. Okay, so where is the second part? Okay, part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries blah blah blah. The badge for efficiency, only item type carried by all 3 elves. Oh, sorry. Okay, so are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item B somewhere in the rack stack. Okay, so we need to find the one that is common to 3 elves. The problem is that someone forgot to put this year's updated authenticity sticker in the badges. All of the badges need to be pulled out. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell is the right one is by finding the one item that is common between all 3 elves. Okay, so here, so we need to group, let's say, lines equals this. So we take these lines, if I'm right. So what we could do is, for I in range 0, or from 0 to len lines 3, we can say that we need to find, I don't know, I will read the statement maybe later, but we could say the set of lines I and set of lines I plus 1 and set of lines I plus 2, C equals print C. Let's see if this works. Yeah, there's a single character, right? So I don't know, maybe we just jump and try to print this. If we are wrong, we are going to I mean, this, I'm trying to go very fast now. We don't know if this will be right or not, but we can try this, and if we get the wrong answer, then we can go back and read the statement again, right? So Okay, is lower. We converted this to a list and got the first element. So this is the number we get. Let's try to get the gold star. Yeah, we got the gold star. Okay, so that was fast. Yesterday we had a very bad day. I was very slow in solving yesterday's problem, but today I was fast. Okay, so we can simplify this code. For example, we could move these lines to the beginning. So we read all of these lines. So we can simplify this line in lines. For example, well, what we usually do, right? We will put an assert here, sol 2 equals this. Let's remove this print and this print here. Sorry, this assertion needs to equal signs. Okay, line in lines. Okay, now we're on track. So now we need to assert that solution 1 equals these two. And now we can refactor this code. It seems obvious that we could define these points. Could go back. So here, it's not called points. What is it called? Priorities, right? So we could name this priority of a given character. Here it's called a type. Well, we could say a type. I like C for character. And this is what we have. So if this is the case, we can return this, else return. Because this is an else, we can do just this. So here it would be sol1 plus equals priority of C, right? Let's see if this works. It does. And this is the same we want to do here, right? But for solution 2. Okay, so this is fine. Later we can see if this should be refactored. Maybe not. Okay, and here we're taking this set of first half and second half and getting the first element in the set. And here we are just traversing all the lines 3 by 3. I think there may be a better way of doing this, but this is in the edge of my knowledge of Python, so I would need to see. I would need to experiment a little bit. What if we do this? Okay. 1, 2. This is taking every 2 elements, so this is not what we want to do. So what we did here, I mean, we could. I would like to rewrite both things as a sum, right? So I would like to do sol1 equals sum of map priority. So we are mapping priority to So we're mapping priority to a list. What list? This for line in lines. So this, right now it's a one-liner that, sorry. Okay, there's a syntax error. I think we need to close the map and the sum. Exactly. Now it got formatted. Okay, so this is correct. So this is a one-liner, which could be good, could be not. Could be not. I wanted to think of a way of taking the first element of a set. How do you get the single element of a set. We should see. We would like to see the set. If we call this a set that only has one element, so what are the things that we can do? So I already tried to do this next, but it is not an iterator. How do you get the... What I'm doing here is just converting it to a list, but there should be a better way of doing this. We should probably check the documentation. Anyway, maybe doing this as a one-liner is not such a good solution. We are getting a very too long of a line. We are going to backtrack a little bit. As you know, in this video, I want to try to find the most simple solution or a very understandable solution, let's say. So we could do also so first half, second half. First half, second half equals this, comma, this. Set of the first half and set of the second half. We convert to a list and we get the first one. I wonder if there's a better way. So what does iter of a set? That's an iterator, and we can get the next element of this. Well, that's interesting. Not sure if that is better. So we could do the next iterator of this. It's a bit of a weird way of doing it, but works too. So we are doing the intersection of these first two halves. And here we can also do, so A, B, C equals lines I plus 1, lines I plus 2, A, B, C, and here we can do the same. Next iterator of this. So this just gets the first element of the... Okay, here I think we closed one parenthesis too much. Okay, so we're getting this ABC. What I'm thinking is that I would like a simpler way of doing all of these intersections and like repeating all of this. This way of doing this, length of the line divided by 2. But well, maybe there is not a better way. So here I think the solution is pretty obvious. Maybe we can. So what we're doing here, this is fine. We find a function of computing this priority for a single character that is working. We're converting this to the number in A. So there are other ways of doing this. So I think in Python we have the, what is the string dot lowercase. There are ways of string dot lowercase. Okay, ASCII lowercase. So ASCII lowercase. We could also do this index A. So that would even be, maybe it is. I mean, this one maybe is shorter in terms of characters, but you need to understand the ASCII characters and so on. But you could also import string, and here we could do return string dot ASCII lowercase. Exactly, here it is in the ASCII lowercase. Dot index C +1. Let's see if this works. Oh, sorry, not X, but C. Yeah, that works too. This is a beautiful way, I think, of using this. Instead of using this uppercase, sorry, +27. So I think that is a good one, right? You find the index. Oh, even maybe there is even a better way. What we could do is we could join first the lowercase, then the uppercase. Sorry. So if we join the lowercase and then the uppercase, I like this one. I like this one better. And we index C and we return 1 plus. Is that right? Yeah, that is right. That is working. So what we're doing is we are concatenating first all the lowercase letters, then all the uppercase letters. So then this way we don't have to put this 27 number, magic number, which is the number of letters that are in the English alphabet. So I like this much better. So we concatenate the lowercase and uppercase letters, we get the index, and we return 1 plus that. So that's beautiful. So this is the priority of a given character. We could also use type. We could use this or type underscore. It's a common way of preventing the clash. So that way we're using the names in the statement. So they call it priority and they call its item type. This letter is the item type. So this is a good one. And then we could still think if there is a better way of refactoring this code here, right? So this is the for line in lines. What we could do is we could have some functions that explain what we are doing, right? So one way would be we could say def intersect halves of a string S, right? So what we could do here is we could do len S divided by 2 and len S divided by 2. So this is the intersection, right? And we could return the next of the iter of this. So here what we would be doing the intersect halves of line. That is right. Let's see if this works. No. Or we are trying to intersect this, but we need to do the sets. So we're intersecting two sets. This works. Okay, so what we accomplished by doing this is that we use the letter S for having this string, and which makes it shorter, but also we have this intersect halves, which explains what this means, right? So what we can do here now is we can refactor this as a sum of map priority to, we could even also map the intersect halves to the lines. Let's run this. I like this mapping syntax, functional programming syntax. We could also do this as a list comprehension. So for example, it would be intersect halves of line for line in lines, right? This is the same. And we could do also the same for priority, but I think the functional programming syntax is beautiful. So here what we are doing is we are first intersecting halves of each line, and second applying the priority function. So we want to do something very similar for solution 2, right? It will not be exactly the same. What we want to do is, so for example, we want to map, instead of intersect half, we could do intersect lines. Let's intersect rows. Let's call it this rows for now, so we don't reuse the same name. So, and here what we would do is so here we're computing this 1, 2, 3, but we could do this in a different way. We could do this with a range. So what we can do is, instead of lines, instead of map, let's replace this map with a list comprehension. Okay, so we are going to intersect rows, we said, for example. And what we want to do here is lines I to I plus 3. For I in this range here. And what we're going to do in this intersection, we're going to map the set to rows. So we're going to convert a set to a set each of these rows. I don't know how we can intersect a list. So maybe we don't want to do this. We want to do S1, S2, S3. And we're going to do this similar thing in which we're going to set S1 and set S2 and set S3. If we do this, this is not going to work because here we're sending a single. Okay, this is wrong. Let's see, set 1, set 2, set 3. We need one more parenthesis. Okay, this worked. So we can remove this part here, and here let's see again what we're doing. We are intersecting rows. So instead of intersect rows, we could do, I don't know, intersect without the rows. We're intersecting 3 elements, finding this single character that we know that there will be because of the statement. And here we're summing the priority of all these elements. And here this is the intersection for every 3 elements. I'm not sure if there's a better way of doing this. Here we're converting this list of 3 elements to these 3 parameters that we're expecting. Intersect. I have one wonder about the range function. If we do step equals to, does this work? No. Oh, there's no keyword argument, so it is like this. Oh, this is a range, so we need to convert it to a list. Okay, interesting. So, well, I like how we did part 1, because we have this intersect halves function. About part 2, I don't like this intersect name, because this is not halves, but and this is also not the simplest code to follow. We could also simplify, maybe, I don't know if this is simplified. We're adding more lines, but here we could say half 1, half 2, and this half 1, half 2. Oh, sorry, this is going to be sorry. Let's see if I didn't mess up. Sorry. So this is a little bit simpler. We could also put it in one line if we wanted. But it makes it a little bit simpler to follow. We could even call this the middle, you know. We could do some typical way of I don't know, we could call this middle if we wanted, and it could be even more clear. So this function is just getting the intersection of the 3 sets and getting the single element. So this is even simpler. Intersect halves, this is the intersect, and here we're just getting these lines 3 by 3 with this range from 0 to the length of lines with a 3 step of 3, and we intersect these elements I plus 3 with the intersection, and we apply the priority. I don't know, I think we can leave it here. As always, let's talk about the lessons we learned. Well, we used the string module, which has some interesting functions, such as ASCII lowercase and ASCII uppercase. These are just 2 lists of lowercase and uppercase letters. We use the index function. So get the index of an element in a list. So that is useful. We used it here, right? We get the index of the element. Then we did some heavy use of the of the ranges. So we already commented this range slices, right? So we have this S from here to here, from 0 to middle, and S from middle till the end, this kind of ranges. Then we used set intersections. So if you do have a set of, for example, 1, 2, 3, I think that works. Let's make sure. Set of 1, 2, 3. No. A set of a list. Well, a simpler way of getting a set, right, is this 1, 2, 3, and this is the intersection, the ampersand 3, 4, 5. That will have an intersection of 3. What else? Well, we use the iter to convert to an iterator. That was interesting. And we used the these are built-in functions, and we use the next to get the next element in iterator. This is a bit of a weird way of getting the first element in a set. Makes sense. What else did we use? Well, we did heavy use of map and sum, but we already covered this in other videos. What's more interesting, for example, is the use of range that we did. We used range in this way. So 3. So this is range start, end, step. So here we went through the list 3 by 3 starting from 0. And finally, I think this is the most advanced or interesting thing we did, right? So when you have a function, let's say f that accepts 3 elements, for example, 3 parameters, so let's call it ABC, we can call this function, of course, with 1, 2, 3, but if we have a list of 1, 2, 3, so let's say L equals 1, 2, 3, we can call this function in this way. Star L. This will do what is called, I think, tuple unpacking. So what this will do is it will unpack these 3 elements in the list and give it to these 3 elements in the which are the parameters of this function f. So well, this is the list of things we learned today. Some of the interesting features in Python that we used today. I hope you liked it. I'm especially proud of this way of implementing the priority function. I think this is a very, very simple way to go and thus use this string module, which can be useful in these cases. I'm not especially proud of this implementation. I think this is a bit of a hacky one-liner that we might want to improve. I don't either like the intersect name. Intersect halves is fine. But anyway, I think it's a pretty short solution. I think it's well written, and I hope you like it. See you tomorrow.